Somewhere at the bottom of the Baltic Sea, tugboats tow a 73,500-ton concrete tunnel element toward a trench dredged into the seabed, a routine so carefully engineered that no one on deck seemed to notice how strange it actually was. Cables lower it beneath the surface, locking it to the elements already in place. One of 89 pieces forming an 18-kilometer tunnel, each joint tested to hold back the full weight of the Baltic Sea for a century. It will be the longest immersed tunnel ever built, carrying both cars and trains between Denmark and Germany beneath a busy shipping lane, cutting a 45-minute ferry crossing down to a fraction of that time once it finally opens. This is the Fehmarn Belt Tunnel, and it's already run a decade behind schedule, before the final element ever touched the seabed. The kind of delay that had already reshaped budgets, contracts, and two governments' patience. Right now, crossing the Fehmarn Belt Strait between Germany and Denmark means a 45-minute ferry ride, packed with cars waiting to board. And that packed queue is the exact problem this 18-kilometer tunnel was designed to erase. That crossing becomes a bottleneck the moment traffic builds up. Weather turns or a ferry breaks down. A fragile single point of failure for a route that millions of travelers rely on every year. In a modern engineering office, planners studied a lit cross-section model of a tunnel that would replace it entirely, weighing a fixed link against the disruption of building anything at all beneath open water. A bridge tall enough to let large ships pass beneath would be expensive and vulnerable to ship strikes. SO engineers chose something else entirely, especially given how much shipping traffic already passes through this stretch of the Baltic. Danish and German officials in a boardroom signed off on an immersed tube tunnel, massive concrete sections built on land, floated out and sunk into a dredged trench, a method never attempted before at anything close to this scale or length. At 18 kilometers, it would immediately become the longest structure of its kind anywhere on Earth, surpassing every immersed tunnel built anywhere before it by a wide margin. An engineer and a colleague reviewed paper blueprints on an outdoor site table, mapping the corridor from Rødbyhavn to Puttgarten, translating decades of ferry schedules into a single fixed line on a map. Survey buoys marked the shipping channel the tunnel would pass beneath, water up to 40 meters deep along the route, a corridor that would eventually be carved 18 kilometers through open Baltic water. Drones mapped the coastal factory site where Denmark would build what's now called Northern Europe's largest construction site, a site that would eventually employ more than 2,000 workers at once. The design settled on 5 parallel tubes, 2 for a motorway, 2 for double-track rail, and 1 central tube for services and emergency escape, a structure inside a structure, built to outlast anything else on this coastline. As a cargo ship crossed the strait at sunset, the factory that would end its ferry crossing forever was already rising on the shore, unaware that a fixed link would one day make its own crossing obsolete. Before any tunnel piece could be placed, a massive dredging vessel began clearing the seabed, spraying sediment high into the air, a job that would eventually move roughly 19 million cubic meters of material. Aboard a survey ship, a hydrographer studied seabed data, mapping the exact path an 18-kilometer trench would need to follow. Data that had to be exact before a single trench wall could be cut. A dredging pipeline pumped sediment onto the coast, part of a plan to reclaim new land rather than waste the material, turning what could have been waste into new coastline instead. A giant cutterhead churned through the seabed, one of the largest marine dredging operations in European history, taking shape beneath the murky water, the kind of operation that had never been attempted at this scale in Europe before. Buoys stretched across open water, marking a trench that would eventually run the tunnel's full 18 kilometers, a line so long it would eventually need to be tracked in kilometers rather than meters. Danish and German workers inspected a section of dredged trench wall from a support vessel, checking depth against the design, checking whether the numbers on paper matched the trench actually taking shape. Along the coastline, reclaimed land formed from dredged material, 19 million cubic meters of soil, repurposed rather than dumped. Enough material that officials decided to build an entirely new nature reserve from part of it. Seen from above, the dredging vessel looked tiny against the sheer length of the excavation stretching toward the horizon. A visual reminder of just how long 18 kilometers actually is. The Danish site engineer pointed at seabed survey charts, cross-checking the trench cross-section against real depth readings, cross-referencing readings that would decide exactly where the first element could be placed. Some of the reclaimed material became a brand new nature reserve, a reef and coastline built as a byproduct of the excavation, a reef and stretch of coastline that didn't exist before this project began. Two dredging vessels worked simultaneously at opposite ends of the trench, racing to meet somewhere in the middle, a decision that shaved real time off an already tight production schedule. At night, floodlights kept the dredging operation running. Dark, open water, swallowing everything beyond the work lights. The dredging crews working in rotating shifts to keep the schedule from slipping further. Workers signaled a crane operator during a heavy lift near the factory dock, guiding equipment too large to move by hand, equipment too large and too expensive to risk moving without exact coordination. An engineer reviewed geotechnical data on a rugged laptop aboard a survey vessel, checking ground conditions along the planned trench, work that had to happen long before the factory poured its first cubic meter of concrete. Rows of soiled sample containers lined a coastal testing station, each one a small piece of the puzzle beneath the strait, each container a small piece of evidence in a much larger engineering decision. A surveyor set a total station instrument on a tripod near the factory site, recording coordinates for everything built afterward, numbers that would guide everything from the trench to the tunnel portals themselves.
As you can see here,
A convoy of barges hauled dredged material away from the trench site, clearing the path for the elements still to come. Trucks and barges moving in a constant rotation to keep the site clear. By dusk, long shadows stretched across the dredging site, the trench substantially complete and ready for the factory's first finished element. The first sign that the hardest part of the underwater work was about to begin. At the Roodbehaven factory, a massive casting basin held several tunnel elements in progress at once, each one longer than 2 football fields, the beginning of what would become Northern Europe's largest single construction site. Workers installed steel reinforcement cages inside a tunnel element mold, the skeleton that would carry the concrete's full load. Steel that had to survive a century of pressure from the sea above it. Concrete poured into the massive formwork as workers guided the flow, building an element that would weigh 73,500 tons when cured. Concrete poured in stages precise enough that no visible seam would ever show. 6 parallel production lines ran at once across the factory, workers moving between them to keep every element on schedule. 6 lines chosen specifically so no single element would ever fall behind the rest. On a scaffold platform, crews finished the surface of a freshly cast element, smoothing concrete that would soon sit on the seabed. A surface finish that had to be flawless before the element ever touched water. Seen from above, a single element dwarfed the workers standing beside it. To 217 meters long and 42 meters wide. Numbers so large that photographs alone struggled to convey the true scale. A factory technician monitored concrete curing sensors from a control panel, tracking a process that couldn't be rushed. Curing that, if rushed, could compromise a structure meant to last 100 years. At night, floodlights lit the factory as silhouettes of finished elements stood waiting. More than 2,000 workers keeping the lines running. A workforce large enough to fill a small town, all pointed at the same 89 targets. A finished mold was carefully stripped away from a cured concrete section, revealing another completed element ready for the water. One more element added to a tally that still had dozens left to go. Workers guided a massive finished element toward the factory's launch basin, the first step of its journey out to sea. The first of many careful movements between factory and open water. Aerial shots contrasted a single completed element against the vast factory grounds. One piece of 89 still to come. A visual reminder that even one element this size was still only a fraction of the whole. Structural engineers checked element alignment with laser tools, confirming tolerances precise enough for a 100-year design life. Precision that left no room for a shortcut anywhere along the process. A finished element floated in the factory's flooded launch basin, buoyant and ready, before its long tow out to the trench, buoyant enough to be towed, but heavy enough that no ordinary vessel could pull it alone. A close-up revealed the watertight gasket fitted along each element's edge, a seal meant to hold for a century underwater, a seal that had to work perfectly the very first time it touched water. On an adjacent casting line, a second element began production. The factory never letting a single mold sit idle. The factory running like a machine that could not afford to stop. A gantry crane moved materials across the production hall, keeping steel and concrete flowing to wherever the next pour needed them. Logistics as demanding as the engineering itself. A worker swept a flashlight through a completed element's interior, inspecting the 5-tube structure before it ever touched water. A final look before an element left dry land for good. A finished element left the factory harbor, towed out by tugboats on the first leg of its journey to the trench. The first of many slow, careful voyages across open water. Tugboat crews secured tow cables to the massive floating element, a job that left no room for a loose knot. The kind of task where a single mistake could put the entire element at risk. GPS-guided barges carefully positioned the element above the dredged trench, aligning tons of concrete to a precise target, positioning accurate to the centimeter over a target 18 kilometers long. On a pontoon barge, crews monitored ballast tanks as the element began its slow, controlled immersion into the sea, a process that could take hours of careful, unhurried adjustment. The element slowly submerged beneath the surface, guided by cables until it settled into the trench below. One more piece locked into a chain that would eventually span the entire strait. Divers prepared to inspect the newly immersed joint underwater, verifying the seal before crews moved on to the next piece, confirming what instruments alone couldn't fully guarantee. Survey teams marked the position of the next element's placement zone, keeping the 18-kilometer sequence exactly on line, keeping 89 separate placements aligned into a single continuous tunnel. Aboard an immersion support vessel, a GPS positioning display tracked every centimeter of the element's descent, data relayed constantly to engineers back on shore. Engineers reviewed sonar imaging of a submerged joint, checking for the smallest gap before certifying the connection sealed. The kind of check that had to pass before any element could be declared finished. A completed stretch of trench now held several elements connected underwater, the tunnel growing invisibly beneath the strait, invisible from the surface, but growing by hundreds of meters with every successful placement. A technician monitored water pressure gauges near a sealed joint. The hydrostatic load of the Baltic pressing in from every side, forces the joint would have to withstand for the entire 100-year design life. At dusk, an immersion support vessel stayed anchored above the trench, its lights the only activity across the strait, the only sign from a distance that anything was happening beneath the waves at all. Multiple support vessels worked simultaneously along the tunnel alignment, each one responsible for a different stretch of the 18 kilometers. A coordinated operation spread across the full 18-kilometer alignment at once. A diver's camera feed showed an underwater joint being sealed, the rubber gasket compressed by the element's own enormous weight. Footage engineers would review closely before signing off on the connection. Ballast water pumped out of a freshly immersed element, the final step before the joint could be called complete. A routine step repeated 89 times before the tunnel could ever be called whole. A completed tunnel portal rose from the coastline, the point where the underwater structure would finally meet dry land. The first visible proof from land that the crossing was becoming real. Inside a completed tube, workers installed ventilation duct sections, part of the safety systems running the tunnel's full length, systems that had to run flawlessly the length of the entire tunnel. An engineer's lit tabletop model showed the planned 5-tube interior, the technical tube housing, cabling, and an emergency escape corridor, a corridor built specifically for the day something goes wrong. At golden hour, the factory and trench site glowed together, several elements already resting in the water below, each one a small step closer to closing the gap across the strait. In a control room, engineers tracked construction progress across multiple screens, coordinating a project spanning 2 countries, coordinating decisions between Danish and German teams working the same deadline. A stress test sensor was installed inside a tunnel element joint, part of verifying the structure for its 100-year lifespan, part of a testing regime meant to catch problems decades before they could ever matter. A test vehicle drove slowly through a completed section of tunnel roadway, the first traffic this stretch had ever carried, proof that the completed sections could already bear real weight. An engineer reviewed structural test data on a tablet at the factory office, checking readings against original design limits, numbers that would decide whether the tunnel's schedule could hold or would slip again. Workers ran a water tightness test with handheld instruments at a tunnel joint, confirming zero leakage before moving on. The kind of test that had to pass every single time with zero exceptions. At night, a completed tunnel portal glowed under floodlights, the dark Baltic Sea stretching out beyond it, a quiet reminder of how much work still remained beneath the surface. Wide shots compared the massive factory against a small coastal town nearby, underscoring just how large the site had become, scale that only became clear once ordinary buildings were placed beside it. An engineer stood at the edge of the launch basin, looking out over water that would soon carry the tunnel's final elements. Elements that would soon leave this basin for good. Inside an operations center, monitors displayed survey and pressure data, part of ongoing checks tied to the tunnel's safety systems. Monitoring that would continue for years after the tunnel itself opened. A printed engineering report tracked a timeline that had already slipped from 2021 to 2024, then 2028, then 2029. A paper trail of delay that stretched back over a decade. At a site meeting, an engineer and colleagues discussed immersion schedules over blueprints, weighing weather windows against deadlines, decisions that could push a single immersion back by weeks if the weather turned. At midday, workers paused for a break near the factory site. Ordinary routine beside an extraordinary piece of engineering. A brief pause in a schedule that rarely allowed for one. Aerial footage from different days showed the same factory view further along each time. Steady progress despite the delays. Proof the project kept moving even as headlines focused on the delays. A hand adjusted a small-scale model of the tunnel and coastline, planning a structure still mostly hidden underwater. A miniature version of a structure still mostly invisible in real life. The open sea trench stretched between two distant coastlines. Most of the 89 elements still missing as of 2026. A visual reminder of exactly how much work still lay ahead. In a boardroom, officials reviewed a large screen showing the project's timeline chart, now targeting 2032, a chart that had been redrawn more times than anyone on the project cared to count. One official's face tightened, reacting to a delayed schedule report. The tunnel now running at least 2 years behind its most recent plan. Frustration that had become familiar after years of shifting deadlines. A drone hovered above the factory, capturing inspection footage no ground camera could reach. Routine surveillance that had become part of daily operations at the site. Workers conducted a final inspection along a finished portal wall, checking every meter before certifying it ready. One of thousands of checks required before any element could be certified safe. A safety inspector checked a harness anchor point on the factory scaffold. One of hundreds of mandatory checks, none of them dramatic, all of them mandatory before work could continue. By dusk, the completed portal glowed at the shoreline, work lights blinking along a structure still years from finished. Proof of progress, even as the finish line kept moving further away. At dusk, cargo vessels still pass busily near the construction zone. The hardest part of this project was never the engineering, but simply staying on schedule. The completion date has slipped 4 separate times since the project was first approved, each new deadline landing a little further from the original 2021 target than the one before it. A European Commission official spoke firmly at a podium. EU flags behind the Commission has contributed 1.3 billion euros to this crossing. Funding tied directly to the tunnel's role in a much larger European rail corridor. In a tense negotiation room, officials from both countries sat across the table. The project's total cost near 7.4 billion euros. Negotiations that had grown tenser as each new delay added further cost. A funding agreement document carried an official seal recognition of the tunnel's role linking Scandinavian and continental European rail networks. Paperwork representing years of diplomatic negotiation between two governments. A calendar-styled chart on a boardroom screen showed completion dates shifting again, this time to 2032. A fifth revision that quietly became the project's most repeated headline. An engineer examined a scheduled delay report with a concerned expression. The road and rail sections now set to open in separate stages. A split that added complexity but let at least part of the crossing open sooner. Outside a government building, flags stood formal against an overcast sky. Fehmarn AS, the Danish state company, now runs the project. An agency now facing pressure from both governments to hold the line on the new date. An official's hand signed a revised project agreement, formalizing yet another shift in the timeline. Paperwork that made an already long project officially longer still. A nearly empty factory dock sat quiet during a work slowdown, the pace of immersion dictated by weather as much as by plans. A pause that cost real time on a schedule with very little room left to give. In a nearby coastal town, residents went about daily life, largely unaffected by the megaproject offshore, daily errands and school runs continuing exactly as they had for years. Two officials from different ministries sat in tense conversation. Disagreement over the project's pace evident in their posture. Tension that had built steadily as each new delay landed on both countries' budgets. At dusk, the open sea trench sat mostly empty, only a handful of elements visible underwater after years of work. A visual reminder that 89 elements is a lot further from 18 kilometers than it sounds. A maritime officer studied a shipping lane traffic map. The tunnel meant to run silently beneath vessels just like these. Traffic that would one day pass directly above a tunnel most ships would never notice. A large cargo ship's silhouette passed near the construction zone at dusk, with only a handful of the 89 elements successfully immersed so far. A snapshot of just how much distance still separated ambition from completion. When finished, the crossing between Rodbyhaven and Puttgarden will shrink from a 45-minute ferry to a 10-minute drive or 7-minute train ride, a change dramatic enough to reshape daily commuting between two countries entirely. It will stand as the longest immersed tunnel and the longest combined road and rail tunnel anywhere on Earth. A title that would stand for years, if not decades, after opening. Right now, it's a construction site with 2 finished portals and a handful of submerged elements out of 89. A project caught somewhere between blueprint and reality. By the time the last piece is lowered into place, around 2032, it will have taken over 2 decades from announcement to opening. A timeline long enough that engineers who started the project may not be the ones who finish it. The sun set behind the factory cranes, a dramatic silhouette forming over water that will one day hide the whole structure. Light catching machinery that has already outlasted 3 of its own deadlines. Pulling back, the full strait came into view. A factory on one side, open water waiting to be filled on the other. One half of the strait already committed, the other still waiting its turn. At night, the strait glowed with distant coastline lights. Ships still crossing on the surface, above a tunnel not yet complete. Ordinary traffic completely unaware of the 89-piece puzzle assembling beneath them. If you want to watch all 89 pieces go into the water one by one, subscribe now. We'll track this crossing until the first car drives under the Baltic Sea, a story with delays built into its very foundation and a finish line that keeps moving.